All right, so NO plus Cl2 give you NOCl, and NOCl they say is a yellow gas. All right. Okay, so they gave you two graphs. One is color intensity of the gas mixture versus time. Okay, but how do you interpret a graph like that? Okay, so one thing you need to know is this. All right, so you have to go back and revise a bit of your kinetics. If this is the product time graph, what you'll realize if you have a reactant A to a product, okay. Firstly, what you need to find out is the final value of the final amount or volume of the product. So this is the first thing. Maybe I call it C naught lah. Okay, yeah. So if the graph has this pattern, 0 to half, this is a time taken T1, and from half C naught becomes 3/4 C naught. Okay, this value here. All right, and if from half C naught to 3/4 C naught, I call this T2. So if T1 is equals to T2, in fact T1 equals T2, right? It's a constant. In fact, T1 is actually a half-life. All right, this is your half-life. So if half-life is a constant, you can see that it implies, what it implies is it's actually first order with respect to the limiting reactant, which is A in this case. All right, so in this question, since they say this excess NO, so the limiting one is chlorine. Okay, the limiting one is chlorine, and you can see the time taken is T over here for the halfway mark, and then they say 3/4 of the maximum, right? 3/4 of the maximum is actually 2T. All right, so yeah, so you can see that the time taken to move from here to here, okay, from here to here, the time taken, and from here to here is the same. Right, so it means there's a constant half-life is first order. So this graph tells you it's first order with respect to the limiting one, which is chlorine. It's okay, so it's a constant half-life, first order with respect to chlorine. Okay, this one you can see that rate versus NO square is proportional. So if we know that this is second order respect to NO, second order. So this is going to be the rate equation, KCl2 NO squared. Okay, NO squared. All right, so this is the rate equation. Okay, so first part, the reaction is first order respect to chlorine. That's right. A possible mechanism for the reaction is as follows. So we can imagine, all right, so if I firstly I'll do this. I'm going to add up both of them, and I can see that it will give me 2NO plus Cl2. Yeah, it still does give me the overall equation. All right, so is this a possible mechanism? Okay, is this a possible mechanism? Let's think. Actually, it is possible. All right, why is that so? I'm just going to show it to you. So actually, we take the second step to be the slow step and the first step to be the fast step. So if this is a slow step, I'm going to write down as rate equals to K NOCl2 NO. All right, and you notice that this one is an intermediate. All right, it's not a part. It's an intermediate. So what you need to do is you have to replace it with one of this and one of this. So now if I replace it with Cl2, one of it, and one NO becomes NO square, including this, right? So this is what the rate equation should look like. Can you see that? So it's the same as the overall. So it's actually possible, provided the second step is the slow step. All right, so I'm going to put a tick here. This is fine. Okay, the rate constant has this unit. Okay, if you notice, what's the unit of the rate constant? Okay, what's the unit of the rate constant? So since it's a third order reaction, right? So I go right now, unit of K. Okay, it's a third order reaction. Rate over concentration Cl2 NO square. So this is actually moles per dm cube per minute. Can you see that? Over moles per dm cube. So you work it out, it's going to be moles minus 2 dm6 per minute. So I think this school question was a bit tricky. It's actually moles minus 2, but over here they put moles square, right? So this is definitely out. Okay, so the answer would be B, 1 and 2.